Hello and welcome to another episode of Modular in a Week. In the last episode we built the 4066 quad gated switch, which is 4 independent switches that switches just one single signal path, so either on or off, so a switch in the middle. Today I'd like to make a sequential switch, which is kind of this one combined with a simple divider where you add a clock and it in a sequence goes through one input to many outputs. And there are many chips that can do this in the CMOS family of circuits, amongst others 4051, 4052 and 4053, which have different amounts of inputs and outputs. So we're going to use the 4051, which has 1 input and 8 outputs. So it's also kind of like a baby 8 because you could technically do that into a sequencer. Let's not get into that. So we're going to build one of those because those are also very handy to have around. In the last episode I built this one from scratch. I think there should be some schematics out there, so we're gonna look at that, and if we don't, I guess we just have to draw I have to draw my own. Before we do that, I'd like to say thank you to my patrons. Thank you. You are amazing and you make this work possible. And if any of you other people like to help me in this endeavor, please do so by visiting patreon.com. And also there's some few extra perks you get when you sign up for that. So with that, let's go to the drawing board and see what we can sketch up. Alright, so I've been spending about 1 week trying to design this and just sitting and wondering how I should do. And here is an overview of what I came up with. So we have the 4051, which is the sequential switch, where you have 1 common input output and 8 individual input outputs, which in turn with the binary input here, so 3 bits, decides which of the 8 is routed to the common pin. And the signal here can go both from the common pin to the individual pins or from the individual pins to the common pin. I want to say that one thing, what the design I did uses voltage plus 12 volts and ground, but reading about the VEE and what this one does. So I believe I connected this to ground in the end, but what you can do is if you want the signal to be able to swing around ground, so you want this one to be able to send both negative and positive signals, then this one should actually be connected to negative voltage, but not 12 voltage. So you can't have plus 12 volts and minus 12 volts. That will fry the chip. I think it has a maximum rating of 20 volts or something like that. So this might be a good time to invest in a 7905 and use, if you already have plus 5 volts in your rack or in your modular, you can use that, or you need to buy a 7805 as well. But so you get plus 5 volts and minus 5 volts. That way this might be even more useful in another way. But as I said, I only connected VEE to ground because I don't have a 7905. Otherwise I would have liked to try that. So to control this, I used a 4516, and this is a bit like in the clock divider. I think we used a 4040 or a 4024, and that would work perfectly, work well in this circuit as well. The negative thing of that is that, or the positive thing with this one, the 4516, is that it can actually go both up and down. So we can move through these input outputs, and we can halfway through just go back, and we can go in between like so. So it's a bit more fun chip. And my friend Jonathan Liljedahl, he also, around the same time that I did or just after I did that EMIS clock divider, he did his own design using the two of these 4516s that he cascaded to get all the divisions that I had, and then he ran it backwards, which means that if you run it backwards, it does become musical. We had a discussion in that video that when the 4024 resets, all the outputs are low. But if you run this backwards, so when it does a reset, all the outputs go high, and that is more correct in a musical way. Go back and look at that video for more information on that discussion. But anyway, because I use this chip, I can do a lot of cool stuff. So we have and that means we have loads of input options here. The normal clock input to just move along. We have the gate enable that is connected to the enable pin here. And what this one is, this is actually a switch that sits in here. And if this one isn't connected to, I don't know if it's ground or V+, we'll see in a bit, then there's no signal here. So then it's just quiet. And I thought that would be a fun thing to have as a switch or an input that you can actually gate the signal while also going through it. And then we have the enable pin, which enables the clock to run and the thing to run down. And you could use that. I think I actually in the end decided not to use this one, but so with this you can stop the clock from running. And then of course the reset, and then this really nifty little detail with the up down that you can choose which way this should move. Finally, up here you have something called parallel inputs. So bit inputs add jacks. So we could add jacks and gates to just add a pre-programmed patch here. But yeah, it was just an idea I had. I didn't add this, but technically you could just put gates in here and just randomly connect these together to each other. So if you want to really add gates and stuff and do even more crazy stuff than already possible here, then you can add 3 jacks more here. And that is also decided with a PL pin here. So if this one is high, it will take this, it will take the output of this one will come from these instead of the clock input. And then I built upon this a bit, and here you can see, so I'm using a TL074 for all the comparators as usual. So this is exactly the same design as the previous gated switch. And of course for that we need the 1N4148. It says 4448, but it's 4148. Sorry about that. All the way down, and these go, and this is to remove the negative voltage that will come out of this as soon as this one is not, as long as this isn't a high. So, and that goes in there. So we have the clock input, of course, we have the gate enable, I choose to have that one, and this one is, so there's a 100k resistor on each input just to make sure that it stays to ground, and I actually chose to put the enable to ground, so there's nothing connected to that one. You can add another diode and another jack or button to have this as well. The reset, same thing, and the up down. Now the up down, so right now it is connected to ground with a pull down resistor, and I actually need to do this a pull up resistor to have it go the correct way, or down I guess is the correct way for as standard when nothing is connected. Right now I need to have it connected to one of the hex inverters just to have a high on the input all the time. Otherwise it goes backwards, which maybe isn't a big deal, but it does. And one more thing, and that is LEDs. I really want LEDs so I know which one of these is active, and I haven't thought of a good way yet. There's of course the possibility just to add another one of these in parallel and just feed the LEDs with that. That would be totally fine. But yeah, I haven't finished that process yet. So it's when I do the, it does take a bit longer when I do the circuit from scratch. And this time I didn't even try to look online to see if I found any other designs. I know there are loads of designs for this, but I just wanted to try it out myself and do something. Which brings us to the panel, which I don't have in my hands yet, but here's the design, and it has gone away to be manufactured. And it's a bit messy maybe, but here we have, and I chose to call them A and B because I didn't want to have input and output, because as I said, it can go both ways, so it might as well be flexible like so. And here I will have a switch, an LED, jack, switch again up down to decide which way it should go, and an LED. When it's lit it's going, so that's wrong. When it's lit it should be going down. I would call down the correct way. The clock with the LED and the reset, and also a button here, a button to press and a button to move it forward. All the controls aren't ready yet when we go and look at how this works, which we are going to do right now. Alright, so here's the sequential switch that's built so far, and because I don't have the panel yet, it's really difficult to build this out. So here we have the 4 individual input outputs and the common input there. And yes, there's only 4 because it's really difficult to keep all 8 in check here. And here we have the gate input, the up-down input, and the reset and clock input, and there's the clock LED. So let's find a clock here. So there we have a clock, and that means that we are now switching in between sounds here. and now it's moving through all the 8 outputs. So we need to reset the pin, or reset after a while, and we do that by taking from the clock divider one that is a bit slower into the reset. And also because it's now we only get one of the tones, and this is because we have the first 4 of the outputs, and it's actually going backwards because I have hardwired the up down to ground. That needs to be a pull up resistor instead of a pull down resistor. So that's why I take input from one of the hex oscillators, which with no input, which means it's just on all the time, and we connect that there, and now it goes from up down on the outputs. We could also, just for the sake of it, add a gate on the gate input so you can hear that. So here we have all the inputs used to get some strange effects. Here I use it the other way around, so the common input-output is the input from a VCO, and then I have 3 outputs going to 3 filters, then that is then going over to the mixer. Just like I did with the 4066, I guess I have to make a follow-up video that is a bit easier to go through the final setup of this one than this mess. Alright, so here's a patch. It sounds like there's a lot going on, which there kind of is. Here I use it as 4 inputs to 1 output. So the common input-output is going straight into the mixer, and the 4 other outputs are so one is going just from a VCO, another one from a hex oscillator, one of them, another one is coming from the AAC VCO that is, you can hear it from time to time changing, so going by a sequencer, so the sequencer is running the AAC VCO a bit now and then, because this one is run from the NAND gate, so just to get a bit of a movement in it. So as you can see, it runs for a bit and then it stops at different note each time around. And the 4th one is actually coming from the MS-20 OTA filter with no input. It's just the resonance of the filter that is self-oscillating, and with CV in from a LFO. And I think that is all that is happening here. There is also a bass drum, that's right. So and this is what that sounds like. So it just, oh yeah, also there's, let's see, there's up down, so it's running on, it's running the from up to down, so down I guess, and also I have the reset also connected to half a step of the clock divider. So that's just to get it running everything. If I take that one out, we get a pause of 4 counts when there's nothing happening, because I only have 4 channels running here. So some effects just to hear what that sounds like. And except for the panel, which isn't done yet, this is it for this episode. And now we have a sequential switch as well, which, just as all the other modules, is good for different things. But for these moving generative sounds, I think this is really awesome. And one of the patches I did with this, I actually recorded half an hour of and I just sat, listened to it for half an hour, and because of the way it moved, it didn't get too boring until the end. Maybe we'll see if I can get that out there as well. Quite meditative, and even though with a bass drum going all the time, it's at a tempo that was quite nice. Anyway, so one of the design choices you can make that I forgot to mention before is that for the reset, you can actually have a rotating switch instead to decide which step you would like to have the reset on. Instead of, for me, I need to find the correct division from the clock divider and add that to the gate input to get correct. And in a live situation, if you were to do that, that might be a bit tedious, and then a rotary switch might be a better choice. One thing more you can do with this that I actually forgot to mention as well is that if you just have a gate input or a high input on the common input, then you can, with the clock, you could actually just make this into a clock divider that you can divide at any number between 1 and 8. So all these strange divisions that you can't get with this one, like divide by 3 for example, you could have just a gate input on this one, and on the outputs, on the third output you would get a divide by 3. So anyway, thanks for watching. Hope you like this and that you find it useful. I will, as I said, make a video once I get the panel done, just like I did for the 4066, just to clear things up a bit. When trying to show a circuit like this and explain it, it does tend to get a bit messy. Thanks for watching. Like and subscribe and do all that if you'd like to, and I'll see you in the next episode. Take care. Bye.